Assalamualaikum and hi to Dr. Ibrahim and everyone. We are from group I9 and we are going to present on coordination compound. And the compound that we chose is chloropentamine cobalt trichloride. My name is Ainsya and my group members are KHIRTANA, RAVEENDRAN, Nur Ainsya, Nur LIYANA and Muhammad ALIF AFIQ. So these are the contents that which we'll be going to discuss in this presentation. So we will go to the first one, which is method of synthesis. So to prepare the chloropentamine cobalt trichloride, first, ammonium chloride is dissolved in concentrated ammonium. Then add cobalt 2 chloride into the mixture gradually until the brown color slurry was obtained. After the brown color slurry was obtained, add hydrogen peroxide and hydrochloric acid slowly. The mixture is heat and cooled to temperature. Then wash the crystals of chloropentamine cobalt trichloride with ice water and small portions of ethanol. All the chemicals used in the preparations of chloropentamine cobalt trichloride were purchased from Sigma Elrich. Below is the reaction equation in order to prepare chloropentamine cobalt trichloride. So next, I will pass to the next presenter.
Okay, next I will explain about the points group determination for our complex, which is chloropentamine cobalt trichloride. Okay, before that, what is point group? Points group is molecules that are classified and grouped based on their symmetry. Molecules with similar symmetry are put into the same point group. A points group contains all objects that have the same symmetry elements. What is symmetry elements? Okay, if you can see the table, we have symmetry operation, symmetry elements, and also the symbols. So first we have identity. Symmetry operation identity, which with symmetry elements, whole of space. What is mean actually? So this means these operations leave the entire molecule unchanged with symbol E. Next symmetry operation, we have rotation by 360 degree per n with symmetry element and full symmetry axis with symbol CN. So later on I will show how these operations works. Next we have reflection. Reflection is mirror planes for the symmetry elements with symbol sigma. And then we have symmetry operation, rotation by 360 degree per n, followed by reflection in a plane perpendicular to the rotation axis. So the symmetry elements and full axis of improper rotation. So note that this rotation is improper with symbol SN. Last but not least, we have inversion with symmetry elements is center of inversions with symbol I. Okay, so here we have two diagram of the chloropentamine cobalt trichloride structure. On top we have 2D structure and below here we have 3D structure. If you can see on 3D structure, we have cobalt attached to 5NH3 and also 1C. Based on the video, we can see that C4 rotation axis is along chloride 2NH3 and it's rotated for 90 degree. Okay, the rotation axis of C2 is same as C4, but it just rotates for 180 degree. Then here is the mirror plane of this complex. This shows vertical plane of symmetry with symbol sigma V. Okay, other than that, this complex also have sigma D, which is the hydral plane of symmetry. So this shows all the symmetry elements in this complex, which are C2, C4, sigma V, sigma D, and not to forget E, which is identity. Therefore, The points group of this complex, which is chloropentamine cobalt trichloride, is C4V with symmetry elements E, C2, 2C4, 2 sigma V, and also 2 sigma D.
Next, I will explain about the type of ligands. First, we must know the type of ligands that present in chloropentamine cobalt trichloride. Is it chloride and ammonia, it is a monodated ligand due to having one point of attachment. Next, we must know either a strong or weak field ligand. Chloride, chloride is a weak field ligand and ammonia is a strong field ligand. And in terms of valence bond theory, ligand field theory, and crystal field theory, first we must check the number of weak and strong field ligands. Based on this, we know that the number of strong field ligands is more than the number of weak field ligands. Second, we must check whether the central metal is a 4D, 5D, or 6D series. And cobalt is a 3D series. And so, based on this, we know that ligand will behave as a strong field ligands due to the number of strong field ligands. So, for the valence bond theory, we must find the oxidation state of cobalt ion, which is +3, and electronic configuration is argon 3d6. So, the electron will arrange themselves, line the 3d orbital like we see in the diagram. And we must take note, because it is a strong field ligand, so electron of central metal ion will pair up, and each ligand will donate a pair of electron. So we can see the electron will pair up and occupy 1d orbital, and the empty d orbital that left will combine with the empty 4s orbital, and 3 empty 4p orbital will combine together to form d2sp3. The D2sp3 orbital will be occupied because each ammonia and chlorine ion will donate a pair of electrons to the metal central ion. And hence, the hybridization, we can conclude that it is D2sp3 and it is inner orbital complex because it's used the d orbital for the hybridization. And there is no spin because of no lone pair electron, thus it will be the low spin complex. Next, move on to crystal field theory. So first we must know the interaction between the metal and ligand are purely electrostatic. Second, we must know the ligand as a negative point charge. So the key point that we must know is in the absence of ligand, the d orbital of the metal are degenerated with the same energy. Second is the presence of ligands will cause the d orbital to be stabilized or destabilized. The diagram show the structure of the 3d orbital. Next, in the crystal field theory, because the compound has strong field ligands, it will produce the large splitting energy, and hence it leads to the low spin. This diagram shows when the degenerated d orbital, it will split into the Eg and T2g energy. Because based on octahedral structure, the dz square and dx square minus dy square will be at high energy, which is Eg, because as we can see, the 3d orbital is pointing directly on this negative charge and is an unstable situation. And this is why the 3dz square and dx square minus dy square, it goes up in energy. For the next part is ligand field theory. From the spectrochemical series, we can see the pi donors, pi acceptors, and sigma donors. Because of we have ammonia and chloride, therefore there are 1 pi donor ligands and 5 sigma donors ligands. Hence, we can conclude that the molecular orbital diagram for the ML6 octahedral looks like this. Next, I will pass to my friend to explain about the spectroscopy technique.
All right, so now we are going to discuss on the spectroscopy techniques that used in determining the chloropentamine cobalt 3 chloride. So the technique used is FTIR spectroscopy, which is an infrared spectroscopy. So in the spectra of chloropentamine cobalt 3 chloride, we can found that there is NH3 bonding at the absorption of 3278 for the stretching of symmetrical stretching. And there's another bond of NH3 at the absorption of 1620 for the degeneration and deformation of the vibration. And then there is another NH3 bond at 1307 for the wagging of stretching, and another NH3 bond at 840 for the vibrations. And also we have the cobalt NH3 at 486 for the vibrations also, and cobalt and chloride at 840 for the vibrations also. So followed by the properties of chloropentamine 3 cobalt 3 chloride. So in general, the properties are it comes in a shape, a rhombed shape crystal, which is in red violet color. It is also known as a water-soluble salt. It has a molar mass of 250.4 gram, and the density, which is denser than water, at 1.783 gram per milliliter. Okay, followed by the magnetic properties of chloropentamine cobalt 3 chloride. What is the magnetic property? So the magnetic property of a material is the atomic or subatomic response of a material to an applied magnetic field, wherein the electrons spin and charge create a dipole moment and a magnetic field. So according to the journal that we have synthesized and analyzed, the chloropentamine cobalt 3 chloride is a diamagnetic. This is due to the cobalt 2 plus ion and the chloride 2 minus ions. The electrons, they are paired together in an orbital, which achieve a total spin of 0. So this explains why it is a diamagnetic property. So that's all from me.
Let us look at the stereochemistry or 3D geometry of chloropentamine cobalt 3 chloride. In this slide, this is the model structure of the chloropentamine cobalt 3 chloride that was made using molecular model. In this video, we will look into the simulation of chloropentamine cobalt 3 chloride complex. From its structure, we can see that this complex adopts the geometry of octahedral and have the coordination number of 6. The central metal ion for this complex is cobalt, which has the charge of 3+, and it has 2 types of ligand attached to it. The 2 types of ligands attached to it is the Cl- and amine group. So 5 amine group attached to the central metal ion, while 1 Cl- is attached to it too.
Lastly, the applications of the chloropentamine cobalt 3 chloride. So, chloropentamine cobalt 3 chloride is doped with polyvinyl acetate to prepare polymeric films, which enhance the optical conductivity. Then, it also used to prepare the corresponding hydrogen sulfate complex by reacting with sulfuric acid. That's all from our group. If any of you have any questions, so feel free to ask. We will try our best to answer your question. Thank you.